Okay. Anyway, if any question regarding to this subject, you feel free to share with me, and I try my best to share what I know and try to solve the problem together. So I start recording, and good evening, and thank you very much for all your attendance. And today, what we will like to have the revision is on the topic of the lighting. As I know, in the last lecture, everyone should be very busy because I read the PowerPoint that there's a schedule. In the front page, you attend two seminars from two speakers. One is the guest speaker from a lighting company. Another one is Professor Dimopoulos. And finally, you complete the class by a quiz. So you're quite busy. And I read the PowerPoint shared in the Canvas. We know you are doing something knowledge enhancement on lighting. So today, we are going to review one of the questions in the lighting. So now I share my screen on my PowerPoint, which, okay. So everyone can now see my screen on the PowerPoint? Yeah, we can see. Okay, that is great. So as far as I know, there's two questions in the assignment. And of course, I have consulted Professor Dimopoulos if it is good to share each other about the assignment before your next lecture. He's okay, of course, otherwise I won't share anything on that. And today we just focus on one question, is 6.2. So here is the question. How many, I would like to ask, did you review this assignment or not? Like he didn't give any assignment for this one. I checked from the PowerPoint. Okay. I checked from the PowerPoint, and also there is a list to do list or list to do. In the Canvas? In the Canvas. Yes. No, yes. There isn't any. You have better check, no matter in the PowerPoint. Otherwise, I don't know because I didn't attend your lecture. But anyway, okay. I think you should learn something about that because I have also finished the reading as indicate which page from which page again on the lighting. Lighting actually is a quite good topic. Even for the energy consumption of the lighting, just take about maybe 15%, 20% maximum on the whole building energy consumption. But when you make the improvement, you just change the procedure. I mean, it's very easy. Maybe just change the light bulb, add the sensor, then you can achieve a very good improvement on the lighting energy consumption up to 50%. So I would say, of course, every one of you may know the large proportion of the energy consumption in a building is the space conditioning. That means the heater, the air conditioning in the summer or in the winter. So it will take a very, very high energy consumption, but you need to do a lot of job before you have an improvement. Like you need to change your window from single glaze to double glaze. You need to change your insulation on the rooftop, on the wall with a better R value. So everything is more complicated, but let's think about lighting, or you just make use of the light bulb. If this area, you think, or maybe you can check the standard, this area is not usually used, just a corridor. But of course, depends. If the corridor is very dark, you can eliminate any lighting. But if it's fine, you don't need so many lighting, or you don't need so high power rating lamp installed on the roof. So when you do the improvement, it's quite simple, rather than you make the improvement on the insulation of the wall, envelope of the building. So it's a quite interesting topic. And as far as I know, one of the elective course is lighting in our program. But I didn't take it, I take another course. But I also heard from my classmate, the lighting course is also quite interesting and very practical, of course. So now let's take a look on the lighting. So I don't think I need to explain the terms like bars, light fixture, light lamps. I think every one of you know about the terms, what does that mean, and what is 120 is the number of the lamp, and the lamp with a 120 fixture here. That means 120 fixture, and every fixture which allow you to put 4 lamps. And I would like to know, anybody know this figure means?
That's a name of lamp. Actually, yeah, it's a name of lamp.
Yeah, it's a serial number. Yeah, it is a serial number. But every number with the meaning. So 40 F is the type of the lamp. Furnace. 40 is the power weighting. T is tubular, the type of the lamp. I mean the streamline, the outlook of the lamp. 12 is about the diameter. So what does that mean? 12, it is not mean 12 millimeter. Somehow it's by number is 12/8, and this number is in the unit of inch. Okay, so this we need to know. It represent different alphabetic letters. Number represent different parameter regarding all the specification of the light. Okay, so contain 34 watt lamps, and with 2 bullets. That means I can see there's some activator to keep the light turn on, some electronic device or electrical device. So it's the original. And how much you can save by installing 3 hyphen. That means this fixture, this is fixture, which install 3 pieces of lamps, and with the specification like that, and the fixture price is 15. Okay, another case, same as A, which we can install 3 lamp with 32 watt, and T8 is about the diameter. And electronic ballast. Electronic ballast compared with normal electrical one, it will have less power consumption. And you can check the lighting handbook, of course, or even our textbook. Some table can indicate roughly the range of the power consumption on the electronic ballast lamp with this specification. You can turn to the page very beginning on the chapter of lighting. It seems it's chapter 6, as I remember, and you can find the power weighting, of course. So assume same energy cost. That means even I switch from 4 lamps to 3 lamps, the energy consumption, I mean the energy cost is sorry, I repeat again. Assume the same energy cost given in problem 6.1. That what is 6.1? It indicates how much you need to pay per kilowatt H. So I just, for easier for you to understand the question, I try to extract the number from 6.1 and put it here. So in 6.1, the energy used, the price is $0.055 per kilowatt H. And the power demand is $7 per kilowatt. And of course, these two parameters is what is given in this question. And first, we need to calculate the simple payback. What is the return on investment? And it also given the lights are on 8,760. How this number will be is 365 times 24 hours is continuous lighting per year, okay? And the life of the lighting system is 7 years. So all those given is for you to calculate the return on investment, because simple payback period, you just need to know the investment, of course, and also the annual cash flow. Then you can get a simple payback period. But return on investment, you need to learn what is the profit and the investment, because after you make the improvement, you can get the benefit, get the saving on the money, on the power every year. So that is the point. You need to know the life of the lighting system. But of course, somehow you can switch, turn over the book and try to find what is the lifetime for such lamp in this specification. Of course, you can do that, but in my demonstration, I just want to make it more simpler for you to understand. So I just simply take the assumption in the question 7 years. Okay, any question on these questions first?
No.
Okay, very good. Okay. Okay, here, what we did, the first idea is build a table and put all the number, all the number here into the table. So let's see. The base case, that means this question, 120 pieces, 4 lamp, F40, T12, which is 34 watts, 2 barrels. So I put all the number and form this table and assume the voltage of the ballast is 12 volts each. So just by not difficult calculation, we can obtain the existing or the base case, the total power consumption. So please we understand, when we calculate the bill, the electricity bill, normally we focus on, of course, not only two, but what we focus on is two. One is the energy consumption, one is the demand. Energy consumption in terms of unit should be HW hour, kilowatt hour. And for the demand cost, we focus on the power because it will charge you per unit of power, okay? So now we put the focus on the demand cost first, the power. So if you still remember, after we calculate the base case, we also need to calculate the first alternative. 3 pieces F40T10, okay? And 120 pieces, no change because of fixture. Every fixture with can install 3 pieces of lamps. And every lamp, as I explained, F40 is 40 power, okay? And 2 ballasts. And of course, there's no indication the ballast is changed. So we take the same voltage of the ballast is 12 volts and make another calculation like this. And finally, F42T8, 120 pieces, 3 lamps, 34 to 1 ballast, because right now they change only N. So sometimes the question is like that. Sometimes it may not very clear to indicate 1, but it's N, just 1 to represent 1, or that's represent 1, but E we use N. Okay, so we do the same procedure and obtain in every class what is the total power consumption. Okay, so any question on these pages?
Like for the ballast, like we will just assume the watt, or just it is given in the question?
It's kilowatt. Yeah, we need to change, of course. Let's take a look.
No,
yeah,
no, not that, like the watt. You wrote assume 12 watt each, right? So it's not given in the question, right? We need to assume it for ballast.
Yeah, ballast. What is your question, in existing or here, right?
Yeah. Why, like we need to assume it, or it's given in the question, the watt for ballast?
No. So here, it didn't mention you can change the ballast.
Okay.
Only the lamp is changed. Okay. So if you don't have the ballast, the light will not turn on, right?
Yeah.
So you are using the current 2 ballast fixture on that, okay? But for B, it's specifically to state that an electronic ballast. So when we're facing this kind of phases, we need to check what is the voltage on this ballast. But for me, before I attend this program, I always need to do the report. But of course, the report somehow is favored. Of course, when you do the report, what do you want to do is favorite your customer, right? Favorite your boss. Otherwise, there's no need for you to write a report to favor myself, okay? So when I facing like this kind of situation, the range from 5 to 12, of course, I will take 5 because the improvement will be more obviously. And also, what I did is within the specification. That is what I follow the standard. I'm not doing something is creative, right? But if I use 12 volt, you may also good, correct, but the improvement on the saving may not so apparently, okay? So somehow I will just use such kind of technique, especially I write a report. Of course, I need to tell the reader, customer, boss, why I need to do such improvement, because you have such saving. Of course, this saving, if I have a choice, this saving or this saving, I will pick this saving. Okay. Hey, I would like to know, can you see my face?
Yeah, we can.
Okay.
Yes.
Because I do many gesture. If you can't,
No,
yeah, it's
okay.
yeah,
It's okay.
okay.
Yeah, we can say.
Okay. Any question on this table?
Yeah, no, it's fine.
No, it's good.
Okay. Let's turn to the next table. So after we know the power on each cases, it's easier for us to calculate the demand cost. And for this question, it's very simple. No matter how much the power, I mean, it charges you the same, $7 per kilowatt. So sometimes if you think, or making a table, in your mindset at least, which can easy to help you to solve every question can step by step. So if you try to understand the logic of this table, why I put this table, why I need to put this parameter, if you know this, and after this tutorial, you go back home, of course, the first time you try to do it again by yourself without watching again this video and try to do, if you can do from very beginning to the end, that means you have learned. When you're facing the same question in the quiz or the exam, or even in the future, some practical proposal, you also know what is the procedure, so you don't need to worry so much. Okay. And also, right now, I also get the advice from Professor Demopoulos and try to so in terms of the table and make you guys more clear about the step and what is the critical parameter we need to consider in order to obtain the answer. Okay. So in this table, power and for the charge, $7 per kilowatt, and we can calculate. This calculation is not difficult. It's 19.2 times 7, then it is the demand cost. Okay. As it is the baseline, the saving, of course, is not applicable. Okay. But for F40 T10, there is a saving. So the saving is this number minus this number, then we can obtain the saving on $13.44. And in the same way, F32TH, we do the same, but not compare these two numbers. We need to compare this base case and 84.84. So we have 49.56. So it also indicate why I pick 5 instead of 12, because if I pick 12, the saving here is only 13.44. But if I or maybe more because it's less power consumption, but it will not the number will not larger than 49.56. Okay, so I just want to reflect our saving is quite obvious. So, and I hope my boss can accept my proposal and work on the improvement. Okay. So now, one more thing, I need to copy another to you. Sorry, guys. A moment. If I suddenly is kick, we all kick and try to oh, sorry. And try this. Okay, this next chat room. Okay. Try to save it. Otherwise, the cut will be suddenly. Nobody can control. Okay, Zoom will terminate our Zoom immediately. So save this link. And after we are kicked out of this chat room, we can access another one. So now we have finished the power and the demand, but it's only one of the component on the electricity bill. What is next one is the energy saving. But of course, if the the demand cost increase, I don't think there's any point the energy will decrease. Of course, it will also increase. So if we make the improvement on the power, that means we also have the saving in the energy. Okay, so we do the same table cases: power, time, energy, how much per unit energy, and total energy cost and the saving. So the number, what we have did, you can refer what we have done and construct this table? Any question on this table?
No, it is clear.
Okay, okay, very good. So what is the total saving? So as I mentioned, in this question, we just focus on two components. One is the power saving, another one is energy savings. But of course, eventually, you may charge with the administration cost or may some surcharge or the fees, especially recently. You all guys know there's a conflict in the Europe, and somehow United States announced to stop the import of the fuels from Russia. So somehow the price of the fuels may fluctuate. So there are many components on the electricity bill or even the gas bill, but what we only focus on these two components is power, demand, that means, and the energy. So that is what we're saving in terms of the power and the energy. Another one is about the cost. And those tables, the calculation, you don't need to recalculate all those again because every table you have already done in the previous slide. And just put the table, the number inside the table and make the final calculation is the total saving, okay? Total saving. On the, of course, we don't need to take care of the base case now. A alternative and the B alternative, and we can get the total saving by adding power or demand saving and the energy saving, okay? So any question on this slide?
No, it's good.
Okay. So it's almost the final step is about what we need to find out. As you guys still remember, we are not just calculate the saving. Saving is just in the very beginning. How much can you save by installing these two fixtures accordingly? We'll assume the same. We also need to work out on simple payback period and the return on investment. And try to remember what is the equation on that. So it gives you simple payback is how much annual saving, that means the cash flow, even loss or gain, but in this case, you have saving. Of course, you gain because you gain from the saving, okay? And the denominator is the investment, the project cost. So as you still remember what you need to compare is the question, the question here, the cost of the fixture. But of course, you can do it more in detail. Let's see, now I switch the fixture. Also, I can eliminate from the lamp from 4 to 3. Yes, you can do it and you can do more in detail, but I just would like to show you the concept. So I just simply assume the difference in the number of the lamp, I mean the cost, is negligible. Otherwise, you can put all the numbers and calculate again. You can simply find the cost structure, I mean the price of F40, F40T10, F32TA from the most simplest way, maybe in the Amazon, even some of the website of the wholesale, and you can get the price in the lower and you can do the calculation. But I just make it simple in this demonstration. So I assume the cost of the difference in the number of the lamp is negligible, okay? So I just put the number on the fixture. 120 is fixed. So in this improvement, we keep the same fixture. We do not eliminate any fixture in the space. Keep 120, but just with different fixture, we have different approach on the installation of a lamp and also the power consumption. So the project cost, that is our investment, 120 times 15. The 15 is the cost of the fixture, and what briefly we obtain the project cost. And about the energy annual saving is what we have done previously here. So by saving, that means saving is a kind of positive cash flow, okay? Annual. That is exactly the same as the definition of the simple payback period. Simple payback period, we normally will, the equation is the project cost over the saving, okay? So if I put the number here, if more investment costs, this value, it will be higher, and less energy saving, and also make this number higher. Okay, so that is the equation. So ultimately, if I invest less and have higher saving, this number will be less, is more optimal. So in this case, we simply can understand 1.92 years, then I can get back my return, okay, for this one. And for this, I need to have 1.45 years. That means shorter period, then I can get the return. That means what I invest after 1.45 years, I can level, okay? So less number here is better, okay, for SPP. Sorry, just confusing you in previous presentation, but now I would like to make the correction, SPP, okay? So here, any question on this SPP first? Go first, yes, okay, and share. So some technique on the Zoom. So everyone can see my screen, right?
Yeah.
Okay, good. So what I said is we can obtain the number and calculate the simple payback period and also the return on the investment. In terms of return on the investment, here I also want to make simple, but of course in question in the midterm exam or future in your work, it may not so simple because every year you need to take the consideration on the inflation or the internal rate of return. What does that mean is if I'm an investor, if I invest this, I need to know the return, of course. But if I put the money to invest on bonds, of course, we have some interest, and this also my return. Somehow the investor is also need to consider if I invest on the lighting improvement program, if I use such amount of money, and also compare with I use the same amount of money to invest on bonding. Normally, we will take the long-term bonding, the treasury bonding, United States as a reference to check if this investment is valuable or not. So that is why we always will take 3%, 2%, 1% on the internal rate of return, the discount rate. So somehow you can learn more if we have time, okay? So, but here is much simple. We don't consider any time value.
No, it's fine.
Okay. ROI, return on investment. And by the equation, the saving times years. Here, we just assume 7 years, but of course, I don't think any lighting can stand for 7 years, but I just make this question more simple and minus the investment, the project cost and over the project cost, and we can get the ROI. ROI, sometimes you may understand how much you can gain on this project. Normally, what we let's say in the capital market, in the security, 30%, 40% is wow, is quite a lot, right? But here is 2.65. That means 2 times 0.65 is pretty good investment. And what I did in before now I'm a student. Before I'm a student, I also work in the management level in the company, and somehow I also need to decide if this proposal is acceptable. I also will take into account how many years I can get my return, and somehow I won't let the project over 2 years and get the return. So there is some sharing in my past. Okay, so any question on this table?
No, but I want to ask one question. Like, can ROI be negative? No, right?
Of course. If you invest and what you gain is not enough to cover your investment, then ROI will be negative.
Okay.
So if that is the case, don't invest.
Yeah.
It's not worth for you to invest.
Yeah.
Okay. And also, if the simple payback period is long, you need to have 20 years to get the return, then stop the idea and find another new one. Okay. Okay. Any question on that?
We are fine.
Okay. Sam, also fine?
Yeah, just on ROI. Yes. 2.65%, right?
Sorry? I can hear very well.
I think he's at work right now. Maybe.
He has.
The ROI is 2.65%, right?
I still can't hear.
He's saying that ROI is in person, right? And
we are in person. You mean you
no,
want to have sorry?
Like return of investment is 2.56%, right? Percent.
Yeah, 265%. Yes,
Oh, yeah.
yes.
Oh, so it is 265%
and 384%. If you multiply 100% on this equation, then you can get the percentage. Okay.
Okay, yeah, I got you. Thank you.
Okay, welcome. So any question?
I think we are good.
Okay. So that is all for this tutorial. If there's no change, I will still keep the same period next week, same time. But if you consult your classmate, if you would like to switch another time slot, I will check my schedule. I will try to do my best to satisfy it, and please let me know. Okay.
Yeah, sure.
Okay. So have a good evening.
Thank you.
Nice to see you again.
Bye.
Bye bye.
Thank you.
Bye bye. Thank you.